So bearings are the crucial element for civil. Everything is, when we talk about coordinates, when we talk about if we're starting from point A and we're going to point B, we have to give that notation a bearing, so a direction. Bearing means direction, as well as a distance. So like we talked about last time, when we measure a distance, we're always going to state it in with 2 decimal places. So if something is 100 feet away, we're going to, when we annotate it, we're going to say it's 100.00 feet. If something is 100.5 feet away, we're going to annotate it as 100.50 feet. Okay, so everything is rounded to the nearest hundredth. So 2 decimal places when we're talking about feet and distance. Now the other component are bearings. So if we look at my screen here and we look at this first image, we have a north, south, east, and west compass. Now, I would assume that most of you are familiar with compass, okay? But that compass is in relation to annotations with just northing, south, east, and west. We don't have any numbers involved. So here we have north, south, east, and west. It's always in that format. North is always up, south is always down, east is to the right, and west is to the left. Okay. If you have problems remembering the order, WE spells we, so it's a word. If you put it backwards, it's not a word. Okay. Or when I learned it in grade school, no one eats soggy waffles, or however you want to memorize it, you have that. Okay. So if we see this circle here, we know that a circle has 360 degrees. Okay. So a circle has 360 degrees. If we split that circle into 4 equal parts, then we would have a quadrant. A quadrant means a fourth of the circle. So when we say the northeast quadrant, that falls between north and east. We have the southeast quadrant that falls between the south line and the east line. Again, we have the southwest quadrant, which falls between the south line and the west line. And finally, we have the northwest quadrant, which falls between the north and the west line. Okay, so there's 4 quadrants to the compass. Okay, each quadrant is 90 degrees because 360 divided by 4 is 90 degrees. Okay, if you look at the image to the right, it's the same exact thing. Okay, we have north up, south down, east to the right, west to the left, always the same. Okay, but what you'll need to know is that in CAD, when we start to draw lines in Civil 3D, CAD knows these quadrants by notations of 1, 2, 3, and 4. So the first quadrant, quadrant 1, is always the northeast quadrant. Okay. Quadrant 2 is always the southeast. Quadrant 3 is always the southwest. And quadrant 4 is always the northwest. Okay. So keep that image in mind, because I'll bring it up next Tuesday when we start Civil 3D. And so you're aware, Civil 3D is very involved. It's very confusing. So we're just starting off with the basics on Tuesday. Okay, kind of walking you through how to get through the program, where things are, and then finally we'll just you'll learn how to draw a line using a bearing and a distance. Okay, so it's baby steps. Okay, but keep this image in mind. Okay, so since the quadrants, we have each quadrant, okay? Each quadrant is divided into 90 degrees. So if I look at this handout, which I posted on the network, or not on the network, on Canvas, okay? This is for you to download, okay? It shows you how a compass can be used for quadrant notation. So when we're talking about a bearing, when we say north something east, or south something east, or south something west, or north something west, that's quadrant notation, because we're talking about the 4 quadrants of a compass, okay? Any questions on that? And I'll get into the math behind it in just a little bit. Okay. Also on this handout, you see azimuth, okay? Azimuth uses the same compass, okay? North is up, south is down, east is to the right, west is to the left, always the same, okay? But what azimuth talks about is that the angle is in relation always to north, okay? So if I was coming here and I was at the north spot here, okay, that would be an azimuth of 0. If I came over to east and I drew a line from the center in the easterly direction, that would be an azimuth of 90. Drawing a line to the south, that would be an azimuth of 180. And west would be 270, azimuth of 270. It always goes in a clockwise rotation, okay? We only have azimuth 0 through 359.9999999, okay? Essentially, azimuth 0 is the same as azimuth 360, okay? All right. So if we have a circle, we know a circle equals 360 degrees, okay? The precision of our, did somebody have a question? Okay. The precision of our technology nowadays, we can divide each degree by 60 equal parts, 60 equal parts, okay? So each degree, a degree is an angle of rotation. Each degree can be divided into 60 equal parts. And those 60 equal parts are called minutes. Now don't confuse it with time, like hours, minutes, seconds. It's not the same thing, okay? Why they chose the same terminology, I don't know, okay? But we have degrees, and when you divide a degree into 60 equal parts, that is 60 minutes, okay? So as you can see down here, I've put this on your handout, okay? 60 minutes. 1 degree equals 60 minutes, okay? So back to around the turn of the century, before World War II, most maps only measured to the nearest minute, okay? After World War II, technology became even better, and then we were able to divide each minute into 60 equal parts, okay? So our technology these days actually is way more precise than how we note it on a map, but we have 1.296 million possibilities in terms of the angle in which a line can be drawn in this compass. So every degree can be divided into 60 equal parts, and each of those minutes can be divided into 60 equal parts, known as seconds, okay? Any questions on that? Okay. Always speak up if you have questions. So here I just made a simple idea, like when we were in grade school and we had protractors and we thought we'll never use protractors ever again. We can use protractors to measure angles, okay? And we can use, I have a protractor at my desk as a professional, because sometimes it's just easier just to kind of estimate an angle of a line than it is to try to figure it out through geometry and sine, cosine, tangent, all that good stuff, okay? Trigonometry. So if I needed to estimate the bearing of a line, I can use my protractor. So my protractor has two different sides. The protractors come in all different shapes and sizes. Some of them are fully round as in 360. Some of them are half circle, semicircle. They, like I said, they come in all shapes and sizes as long as they're round, okay? So this is just to give you an idea of how to annotate a bearing, okay? Bearings always start with either a north or a south letter, okay? They always start with either a north or a south letter, okay? And they always end in either a west or an east letter, okay? So if I'm drawing a line from the center of this circle and I'm coming out in this direction, this line falls between north and east, okay? So I know that the bearing is going to be start with an N and end with an E because it falls between those two letters, okay? Once you understand that, a bearing is always in relation to the first letter. So the first letter is an N, so I start at N and fall towards the east, okay? I start at the N and fall towards the east. Bearings are always in association with the first letter, okay? Not the second letter, the first letter. So if I start at 0, okay, 0 is the vertical line here, and I fall down here, I'm looking at these lower numbers just to make sense, okay? It comes at 45, 46, 47, 48. So this would be north 48 degrees. We're just assuming that it's exactly on it. 0 minutes, 0 seconds east, okay? We always want that type of notation. We want 2 places for degrees, 2 places for minutes, and 2 places for seconds, okay? Here, this example up here, this line is 1 degree falling towards the east. We start at N because it falls between north and east, okay? It's 1 degree past the vertical line, so it's 01. We don't just put 1, we put 01, okay? That's the standard, okay? 0 degrees, 0 minutes east, okay? All right. Hopefully I'm not being repetitive, but I just want to make sure everybody understands, okay? Let's come over here to the west line, okay? The west line falls between, it can either fall between the north and the west, as I've indicated here, or it can also fall between the S and the west, okay? So you could either call that line, the bearing of that line, we fall 90 degrees to west, so we could either call it north 90 degrees, 0 minutes, 0 seconds west, or also equally correct, we could call it south 90 degrees, 0 minutes, 0 seconds west, because if we started at south, rotated 90 degrees to the west, that would also be correct. Okay, so there are some bearings that mean the same thing, even though their annotation is different, okay? Now, if I start at this dot right here, okay, and I walk in the northeasterly direction to where the line ends, as we talked about, it would be annotated north 48 degrees, 0 minutes, 0 seconds east. However, if I started right here and then walked towards that dot, that bearing would be south 48 degrees, 0 minutes, 0 seconds west. So depending on the direction that you walk or would walk depends on the bearing. So a north 48 degrees, 0 minutes, 0 seconds east is equal to south 48 degrees, 0 minutes, 0 seconds west. You just flip the N would be an S and the E would be a W. Okay? Because if I took that line and moved it over here, it would come to the 48. And you can just draw a line and then measure it however you wish. And you can see that depending on the direction that we're walking, those two bearings are equal. For this one, the opposite of north 20 degrees, 00 minutes, 0 seconds west is the same thing as south 20 degrees, 0000 east. Okay, so anytime you see, or you will see on maps, sometimes bearings will kind of mix you up and you'll think, wait a minute, that doesn't make any sense. Well, that means they annotated it opposite. Okay, so just be aware that anytime you see a bearing, you can always change, as long as you change both letters to the opposite letter, it still is the same bearing. Okay? Okay. Alrighty, so let's see. Any questions thus far? Reset. No questions. Okay. So on your agenda, I've put just a simple image here for you to see exactly what I'm talking about. We're starting at either north or south and rotating either towards east or west. Okay? So you start your bearing with either the N or the S, and you end in either the W or the E, depending on the direction that your line moves. Okay? Okay. So
I have a question.
Yes.
If you change the letters of the bearing on one, should you change the letters on the bearings on all other ones, or no?
No, not necessarily.
It's just to make it easier for you to
visualize it. Yeah.
Yes. Okay.
Yeah. When we get into actually annotating, the standard is annotating in a clockwise rotation, so I'll show you how that works
Okay.
later on this evening. Okay.
Okay.
Okay. And that was Romina. Okay. Okay. So there's two types of angles, or how we measure an angle. Okay. We have one that's decimal degrees. Okay. As you can see on your agenda. And the other is in degrees, minutes, seconds. Okay. So I'm going to pop over to my iPad and we're going to make sense of all this. Let's do this, share. Oh, I have to make myself more. Make ghost. Okay. Share. Yes. Okay. So everybody can see my screen. Alrighty. So what we're going to do is I'm going to get my calculator up. So decimal degrees, you'll see me annotated as DD, okay? Always. DD is decimal degrees, okay? And degrees, minutes, seconds is always DMS. Now, if you have a scientific calculator, you may see a DD, you may see this on your calculator, or this. If you have a scientific calculator, you may see that and you may have never known what that means. Well, you're going to use that if you have that on your calculator. If you don't have it on your calculator, I'm going to show you how to calculate these things manually so you actually do understand why it's working the way it is, okay? So anytime we have a decimal degree is, like we discussed before, we will only see on the azimuth compass, okay? The only time we'll see a degrees, minutes, seconds is when we are working with the quadrant compass, okay, the quadrant notation. So we have azimuth notation, decimal degrees, quadrant notation, degrees, minutes, seconds. And we have to be able to toggle between the two depending on what we're trying to measure, okay? So if I had an azimuth of 45.5 degrees, okay, I want to know what the bearing is of this line, okay? Now, what we discussed before was we have one circle equals 360 degrees. We have 1 degree is equal to 60 minutes, and we have 1 minute equals 60 seconds, okay? So we know all those three components, and those three components are helpful when we're trying to calculate these, converting a decimal degree to degrees, minutes, seconds, and vice versa. So here we're going to say we want to split this thing apart, okay? We want to split this thing apart. So keeping that in mind, that you have those equalities, okay, I want to split this angle into pieces so that I can make sense of it. So I have 45 degrees and I have a half a degree, okay? I already know what that is. I mean, it's a whole 45 degrees. What I do need to do is convert this into minutes and seconds, okay? Alrighty. So what I'm going to do is convert the 0.5 degrees times 60 seconds per 1 degree, okay? The reason why we do it this way is so that anytime we have the same units on the top of the fraction as well as the bottom of the fraction, or the numerator or the denominator, however you want to call it, okay? As long as you have the same units both on the top and bottom, they cancel, they equal 1. Anything times 1 is itself, okay? So I can cancel that and I can cancel that, and I'm left with minutes, okay? 60 times a half is 30, okay? So an azimuth of 45.5, okay, if I was to kind of visualize where that falls on a compass, 45.5 will fall somewhere in here, okay? Because as we discussed, azimuth is always in relation to north, okay? And it is measured in the clockwise rotation. So 45.5 degrees away from north in a clockwise rotation, it would fall where that green line is, okay, approximately. So the bearing here, if that's east, that's south, that's west, okay? It has to start with an N because it's above the WE, it's above the west-east line, okay? So it starts at the N, okay? And it ends with an E, okay? And we have 45 degrees because we had 45 full degrees. And this half a degree is equal to 30 minutes. And then we write 00 seconds, okay? Let me write that a little better. North, 45 degrees, 30, 00, east, okay? So anytime you see a half a degree, that's 30 minutes, okay? All right. Does that make sense, everyone? So if we go into a little deeper, a little more involved problem, if I said what is the azimuth, if the azimuth is, let me calculate something real fast. 222.59 degrees, okay? If the azimuth is 222.59 degrees, what is the bearing, okay? So we have to be able to visualize, again, where this would fall. So I always draw my little cross in my circle, okay? So the first quadrant is 0 to 90, so we know that it's past that. The second quadrant is 90 to 180, so we know that it's past that. And then the third quadrant is down here, okay? This is the third, this is the first, this is the second, and this is the fourth, okay? So the third quadrant is 180 to 270. So we know that it falls between 180 and 270. So we're in quadrant 3. Okay. If we're in quadrant 3, this is south, this is west. I know that my bearing is going to start with an S and end with a W. Okay. It's going to fall, let's see, approximately there somewhere. Okay. So I know that it begins with an S, ends with a W. But now I need to convert it so that it looks like a bearing, okay? So I'm going to erase these. And again, this is being recorded, so all of this is available in your notes, okay, as a recording, okay? So if I have $90 degrees here, I have 90 degrees here, what is this remaining angle here? It would simply be 222.59 minus 180, okay? Because my angle is going all the way to there, okay? So 222.59 minus 180 is 42.59, okay? 42.59 degrees, okay? So because it's 222, that tells me what quadrant I'm in, okay? Then I need to reduce it to something that makes sense in a bearing. If you keep in mind that a bearing can only be 90 degrees or less, depending on the quadrant that it's in, you'll be safe, okay? If you wrote a bearing with something greater than a 90-degree angle, you know you've done something wrong, okay? So your bearing always has to be 90 degrees or less, depending on the quadrant that you're in, okay? So we reduce this to 4259 because we know we start at north, rotate clockwise. We have two quadrants that we've gone by completely, which is 180 degrees. 90 plus 90 is 180, okay? So 180 from 222.59 is 4259, okay? So I'm going to use this component to calculate my bearing, okay? Alrighty, so 4259, 4259. So I have 42 full degrees, and I have 59 partial degrees, 5900ths partial degrees, okay? First, I need to convert 0.59 into minutes. So I just take 0.59 degrees times 60, thank you very much, 60 minutes per 1 degree. Those cancel, and let's bring up my calculator. 0.59 times 60 is 35.4 minutes, okay? But now I have to reduce those fraction minutes into seconds, okay? So if I get rid of that so I can make room, okay? Let's do a different color. I have 0.4 minutes times 60 seconds per 1 minute equals 24 seconds. Okay, so let me write this down so I don't lose it. So an azimuth of 222.59 is south 42.35, 24 west. Okay. So the azimuth of 222.59 equals south 42 degrees, 35 minutes, 24 seconds west. Okay, so that's your bearing, your equal bearing to an azimuth of 222.59. Okay, azimuths will always be rounded to the nearest hundredth, so 2 decimal places. Bearings will always have 2 degrees placeholders, 2 minute placeholders, and 2 second placeholders as your final bearing. Okay, you won't see decimal seconds in a final bearing. Okay. Okay. Does anybody need an additional example? Okay. Doesn't sound like it. Okay, so that is bearing. Now let me come back. Now if we had to go back the other way, if I had a bearing of north 60 degrees, 25 minutes, 35 seconds west, and I say, what is my azimuth? That would be something that you would have to do in industry, okay? What is my azimuth? So here I pull this thing apart, just kind of in the same way as we did before, but it's backwards, okay? So we're going from DMS to DD, degrees, minutes, seconds to decimal degrees. Okay. Sometimes you'll be in industry and you'll need to convert one way or the other depending on where you are. If you're working out in the field and you're using instrumentation, instrumentation uses Azimuth. When you're looking at mapping, you're looking at DMS. Okay, so you need to be able to convert the two. Alrighty, so if I need to convert this into Azimuth, I pull it into 3 equal parts. Okay, but first I want to look at what quadrant I'm in. So I'm in the northwest quadrant, so that's quadrant number 4. Okay, quadrant 4. Okay, if I could only write on this thing. Okay, so quadrant 4 is our quadrant. Okay, because we're starting at the north and falling towards the west. So here I have, I'm going to pull this into 3 parts, 60, 25, and 35. 3 equal parts. Okay. This is already in degrees, so I'm done. I then need to get this into degrees and this into degrees. Okay. So if I have 25 minutes, okay, to get it into degrees, I need to multiply by 1 degree per 60 minutes. Okay. So it's opposite. Okay. So we say 25 divided by 60 is, I'm going to write this down, 0.41666. Okay. So that equals 0.416666 continues. Okay. Whenever you're converting bearings to azimuth, always go to at least the 6th decimal place and then round at the end. Don't round in the very beginning because you'll get the wrong azimuth. Okay. So anytime you do rounding, always do rounding at the very end. Okay. All right. So we have 25 minutes converted into degrees is 0.416666, so forth and so on, degrees. Okay. So I have that one done. Now I have to convert 35 seconds into degrees. Okay. So I'm going to get rid of that. And again, it's recorded, so you have that. So I have to convert the 35 seconds into degrees. So I'm going to multiply this by, we know, 2 equalities. Okay, first I need to get it into minutes. 60 seconds. 1 minute equals 60 seconds. So the seconds cancel. And I'm left with minutes. And then I also know that 1 degree is equal to 60 minutes. Okay, and the minutes then cancel. And I'm left with degrees. Okay, so anytime you're going from a bearing, quadrant notation, to azimuth, you're going to take your minutes and divide it by 60, and you're going to take your seconds and divide it by 3600, because 60 times 60 is 3600. Okay, so 35 divided by, let's go to my calculator, 35 divided by 3600 is 0.009722 degrees. Okay, So I realize my screen is small, but so what I've come up with thus far is I have 60 full degrees, and then the 25 minutes is equal to 0.416666 degrees, and the 35 seconds equals 0.009722 degrees. Okay, and all I have to do is add those three numbers together. So I take the 60 plus 0.416666 plus 0.0097, and that equals that equals 60 degrees, 60.42638 degrees. Okay, but I'm not done because I need to put it in azimuth notation. So I'm looking at here that we have the azimuth. So north 60, approximately north 60 is around here somewhere. Okay, we know that azimuth is starting from the north and rotating clockwise to the line. Okay, now northwest, we start at north and we fall towards west. So this 60 degrees is just for this pi right here. Does everybody understand that? It's that piece, that angle right there. So our azimuth has to be 360 minus that angle, because I need to know the blue arrow, not what I've shaded in green. Okay, because it has to be clockwise. So my azimuth really is AZ, we always say AZ, 299.57 degrees, because I round to the nearest hundredth. So those azimuth and bearing are equal. Now, if you get to a resulting azimuth, if you want to check your work, especially on a quiz or a test, try to convert it back to the original bearing. If you come up with the same thing, then you know you've done it right. If you come up with two different things, you might want to revisit it. Whenever I provide quizzes that are timed, you get plenty of time to take it. It's usually 3 times the amount that it should take. So you have plenty of time to check your work, okay? You're not rushing and stressing and doing all that, going through a test. You get plenty of time to take a quiz or a test, okay? So that's how you go back and forth, okay? Notice on the, when I converted the bearing to 60.426388, I didn't round that to hundredths and then subtract it from 360, okay? Now on this case, it would have worked if had I rounded it to 60.43, okay? But just in case, to make sure that I don't have a rounding error on my azimuth, I always do the rounding at the very end, okay? Okay. So that is the conversion between decimal degrees and degrees, minutes, seconds, okay? Here I've given you examples of the various notations, okay? You have quadrant notation, you have azimuth notation, and you have compass notation, okay? Compass is just basically for your information. I'm not going to test you on compass notation, but a lot of you might be familiar with a compass. So this is how the compass relates to quadrant and azimuth, okay? You do need to know this guy. So if I do this, you do need to know this one. And you do need to know what quadrant it would fall in, okay? This is just FYI. Compass notation is FYI, okay, for your information. So below is what you would see on a normal compass, okay? Any annotations you see here are, I've kind of given you an idea of how things would break down. If you want to just practice to make sure you can convert a bearing to an azimuth, here's 5 examples right here that you can just check, okay? Specifically, these 2 would be helpful. Make sure that you're going in the right direction, okay? But just so you're aware of how to read a compass, north and south is up and down, east and west is right and left, like normal, okay? Northeast is exactly in between north and east, so it's 45 degrees from north and 45 degrees from east. Southeast is 45 from east and south, and so forth and so on, okay? Then when you split the north and the northeast down the middle, when you're closer to the north, it then becomes north-northeast. And when then you're closer to the east, it becomes east-northeast, the halfway points. Okay. And then you can break that down again into another half. So it becomes very confusing. So it's, like I said, it's not required for this course, but just to make you aware, if you ever come across a compass, this is how you would read it. So if you have an east and you're between an east and an east-northeast, it then becomes an EBN, which means east by north. So it's closer to east, but it's in the direction of north. So B means by, okay? I think of it as being but, east, going east, but a little bit north, okay? West going, but going a little bit north, okay? Here I'm closer to north, but a little to the west. So that's how I think of it, right? But you can try to, you don't have, like I said, you don't have to memorize it. So, but that's how I think of it, okay? So that's a compass. Here on this compass, you can see azimuth all the way around, okay? So if you have a compass handy, if you know somebody that has a compass, just look at the compass. You can actually download apps on iPhone and Android. You can download the compass, measures in azimuth, so you can kind of visualize it. We use that all the time in the field, okay, if we need to know our azimuth. But that's available there for you, okay? So that's the compass. Does that make sense, everyone? Any questions? And I know I'm going through it quite quickly, but we have a lot to cover this evening. So if you run into questions over the weekend, just shoot me an email and I should be able to respond since I'm available all weekend. Okay. Okay, so I've made links for you here on the quadrant, azimuth, and compass. So you can just open the link and it shows you various images if you want to read more about it. Azimuth's the same, compass, this is the one from the compass website. So anyhow, so you're able to download those and read those if you wish, okay? Now I'm not going to go into radius delta length just yet. I want to get into the meat and potatoes of this lecture, and that is I've put this handout on the website on Canvas for you so we can walk through it this evening. Okay, so we have about an hour and 15 minutes left of lecture, and I just want to make sure that everybody understands how this all comes together and makes sense. Okay, so what you see in this boundary or this border is this black border. We would call this a property line. Okay, the property line is noted by a phantom 2 line type. Okay, phantom 2. It's a long dash followed by 2 dashes followed by a long dash and so forth and so on. Okay. You'll see various annotations on here that I've given you. Okay, this is a full example of all the steps that I would do to solve this problem. Okay, and I've also put another example on the Canvas for you to practice and work through over the weekend so that you can present questions on Tuesday for the class so that I can make sure that everybody understands how to do these calculations. If you don't understand how to do these calculations, you're not going to get very far in this course, nor are you going to get far into the industry. So this has to be practiced. Sometimes it can become tedious, but it has to be practiced and mastered for you to be successful. And just take it one step at a time. It may look like Greek to you right now, but you'll gradually get it if you practice it. Okay. So what I've done for you is I've put a compass, a north compass on each corner. And essentially what we're doing here is we've created 5 math problems. Okay. This shape has 5 sides. So there's 5 math problems to figure out what we want to figure out. What we want to figure out is the bearing of the 4 unknown lines, and we want to calculate the angle of the unknown angle. Okay? Okay. So as I presented last time, internal degrees is this equation up here, n minus 2 times 180. Okay, n meaning the number of sides. So the shape has 5 sides. Okay, the shape has 5 sides. So 5 minus 2 is 3 times 180 is 540 degrees. Okay, that means the total degrees, when I add them all up, has to be 540 degrees exactly. Okay, so that allows me to solve for the unknown angle. So I take 540 as I've typed here. Okay, 540 minus the angle, the lower angle, minus the west angle, minus the northwest angle, minus the northeast angle, and I come up with 116,087,451 degrees. Okay, this D in parentheses is degrees because in my PDF I can't put in a degree symbol, so just know that the D in parentheses means degrees. Degrees. Okay, I don't want to convert it to a bearing just yet. Okay, so just use it as you see them here. These are all to 6 decimal places. Whenever we're calculating bearings, always use at least 6 decimal places. If your calculator gives more, fine. Okay, the more precise you are. If you use less than 6 decimals, your bearings will be a little off. Okay, and then when we go and try to draw this thing next week, it won't close. We talked about closed traverses last time, as well as open traverses. Closed traverses close at the same point as you begin. Open traverses do not close on each other, so that means they cannot hold an area. We always want them to close, be a closed traverse, okay, or as close as possible to a closed traverse. So we've calculated the interior angle that was missing. Okay. Now you'll see on the bottom of the screen, you'll see a POB. POB in land surveying terminology means point of beginning. Okay? Point of beginning. Okay? Means point of beginning. So that means the point in which we will begin our measurements. Okay? So we're starting on the lower corner, the southerly corner, and we are going to move in a clockwise rotation. So the first line that we want to figure out the bearing of is this line here that's annotated with the 70.73 feet. Okay? Okay, so I'm going to move down here. Okay? And what I need to do is I need to figure out the angle of B, which will give me the bearing of that line. Because bearings come from either north or south and fall to either the east or the west. Okay? Okay. So if we understand that, if we understand how north falls towards west, west would be over here, okay? Over here, okay? I'm given a full angle from here to here, 101.898077. Okay, that's the full angle. I can figure out what A is because I'm given a bearing here. This bearing, anytime we're adding or subtracting angles, we always want to convert it to a decimal degree. Okay? Now remember what I said. Depending on the direction that you walk, the bearing can be, for example, on this one, south and west, because I would be going from the upper right corner to the lower corner. But if I was to walk from the lower corner to the upper right corner, that would be an N and an E, northeast. So they're the same angle. Okay? So if I need to figure out what A is, okay, what A is the angle between N, the north line, falling towards the property line, which is that bearing. So I have to convert 47 degrees, 30 minutes, 30 seconds into a decimal degree. Okay? Here I didn't do my precision, but it really doesn't matter because it's exact. Okay? So 47 degrees, 30 minutes is the same as 47.5 degrees. That gets me A. To find B, I take that full angle and minus A. That full angle minus A, which is 47.5, equals 54, 39, 80, 77 degrees. Okay? You're trying to find all of the components so that you can figure out the bearing of each line. Okay? So if I move to the next one, here I have repeated what I did before so you don't get lost. Okay? A is 47.5, okay, which we calculated before because we had that bearing, 47.30. We calculated what B was from the previous slide, okay? So that means I can calculate what C is, okay? We know that a quadrant is 90 degrees, always. So if I know one component of that quadrant, I can always calculate the other component of that quadrant, okay? So if the quadrant is 90 degrees, C will equal 90 degrees minus the number of B, which equals 35, 60, blah, 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 okay? Why do I need that? because I've calculated B, which gives me the angle of that line. So essentially this number right here, 54, 39, 80, 77, will be used for the bearing of that line. But I like to do all my bearings at the very end just to make sure my math is correct. Okay, but you will use that angle B will be the bearing of that line because we start at north and we fall towards the west. Okay, I need to calculate C because these are opposite angles. If you look at, let me try to draw something on here. Draw. This, this, this. These are opposite angles. Now you don't have to know geometry, but this is how it works. If you visualize this north line and this north line, they're parallel. Okay? And we know what parallel means. We've talked about that before. The west and east line on this compass is parallel to the west and east line of this compass. Okay? So because these are parallel, the north line is parallel to the north line, this angle that it makes, C, is equal, it's the opposite angle. So they're both equal to one another. This is equal to this. Okay? I need to know this so that I can calculate this. Okay? So that eventually I can calculate the bearing of that line. Okay? All right, so I have C, 90 degrees is B, or C is 90 degrees minus B, and I calculated that. Okay? Therefore, D, angle D, is 89, 123, 956 minus C equals this. Okay? All right. So here we have the next component. We calculated C and D before. Okay? Calculated C and D before. If I have D here, I can have D there. Okay? If I have D here, because they're opposite angles, the norths are parallel, the east and west lines are parallel, therefore these opposite angles are equal in terms of degrees. Okay? So if I have D, I can then calculate E because I know a quadrant is 90 degrees. Always just remember quadrants 90 degrees, half of a circle 180, full circle 360. As long as you know that, you should be fine. Okay? But you just have to do this in very small sections. You can't just take it all on at one time and try to make sense of it. You have to break it up into parts. Okay? So here I have D. Then I can calculate E because 90 degrees minus D is that. Okay? All right. F is a full 90 degrees, so I can automatically annotate that. And I want to know what that little angle is where G is. Okay? All the little parts. So G is 138, 732, 385. Okay? Minus E minus F. That's what G equals. So E plus F plus G is 138 and some change. Okay. So I calculated what G equals. Okay. Once I know G, I can then calculate H. Because again, this is a quadrant, so it's 90 degrees. So I take 90 minus G is 77 and some change. Okay. And again, this is for you to download so you can study it. Okay. All right. Oops. Okay. So we've defined all these guys from the previous slide. Okay. H is opposite. There's an opposite angle, so those are equal. G is opposite, so those are equal. Okay. So I have a full angle of 94 and some change from the dark line to the dark line. Okay. So 94 and some change minus H equals I, which is 16.4, so forth and so on. Okay. So as you get closer to the end, the less calculations you have to do because you have all the puzzle pieces already to guide you through. Okay. So we go to the next slide. So previously we calculated GH and I. Okay, GH and I. Okay. We know that this is the same because they're the opposite angles. Okay. And I need to calculate J. The reason why I calculate J is because I want to check my work and make sure that this line, when I'm doing my math, comes out to what I was given. And I'll show you in just a second what that means. Okay. So we calculated that angle, 116. Okay. I know from north to south is 180 degrees. You can do this in multiple steps if you want to break it down into 90 and 90. But if you wanted to use it as a 180, a line is 180 degrees. So from north to south is 180. So I take 180 minus I, because I know what I is, minus 116 and some change is J. And I come out with 47.5 degrees. Okay. I come up with 47.5 degrees. 47.5 degrees is the same as 47 degrees 30 minutes, so I know that's correct. If I came up with anything other than 47.5 degrees, I knew I made an error somewhere along the way. Okay. So because I started the POB, point of beginning, I found all of these angles. So the bearing of, let's say, line number 1, I've just labeled it number 1. Line number 1 is going to be this converted into DMS, degrees, minutes, seconds. Okay. So here I've shown you a solution for number 1. So again, we break it into pieces, 54 full degrees, and I have 0.398077 partial degrees. So I convert that into minutes, and I have a remaining decimal. So I convert those minutes into seconds, and I have a remaining decimal. Okay. Now when I put it here, keep those decimals just handy for when you're going to draw this thing. Okay. Decimals are helpful when you're drawing, but when we're annotating, we want it to show just what I've put here on the bottom. Okay. but instead of putting the D in CAD, you'll put the degree symbol. Okay, because PDF doesn't allow me to put the degree symbol. So keep both numbers handy when you're calculating. Okay, keep as many decimal places as you can for when you're going to draw it, but when you annotate it, you have to have 2 placeholders for degrees, 2 placeholders for minutes, 2 placeholders for seconds. Okay. Here I've given you the answers for line number 2, line number 3, line number 4. Those are there. So you should be able to work your way through it and try to calculate them so that you match. Okay. And that's how you do the boundary. Any questions? I know I've gone through a lot. Okay. So what I want to show you is, so that is obviously for you to be able to download. And again, practice makes perfect, or close to perfect. So make sure you go through this and try to work through it. Maybe try to work through this first one as though, just print out the first sheet and then try to solve everything and then compare and contrast to the answers. I've also created this one for you, very similar, okay? Actually use the same line here, okay? You should be able to calculate or work yourself through calculating the angle here, as well as the bearing of the 4 lines, okay? So solve for the bearing of each line. This again is just practice, but I want you to go through, treat it as though it was a homework, because you will have a homework similar to this, but it will be more difficult, okay? It will have more than 5 lines.
I have a question for you.
Yes.
Do you have to calculate these when you're out in the field?
Sometimes, yes.
Okay, because you said you use a fancy machine. Does it calculate these things
No.
for you?
No. No, it does not. You
Oh.
have to be able to look at a map, and like if I'm looking at a map, here, let me see if I can pull something up. Let's see. I created a job. Arcata. Calc. Let's see. I'm trying to find something that you can read. All right, here's a simple one. So here's a map. We want to go, when we're searching for these property corners, okay, on this map you'll see it says set concrete nail with brass tag stamped LS2725. What that means is that a particular land surveyor, licensed land surveyor, his license number is 2725, registered with the state of California. He set a point here. He set a nail in the ground in concrete with a tag. Tag is a metal tag indicating this exact spot in the world, okay? For me to be able to find that, retrace his steps, I don't know where it is until I find at least 2 points, okay? And that takes just practice and a bit of luck. But let's say I found this corner here with the circle, and I found this corner here, found this corner here, and I found this corner here, okay? And I want to know approximately in the direction that I need to walk to find this corner here, okay? Well, I have a bearing of 83.55 to here, and I then have a bearing of 8703 to here. I should be able to calculate the angle between the two so that I kind of have an idea of the direction that I need to walk to here.
That makes sense.
Okay?
Yeah, that makes sense.
Okay. In a simple example, that's why we're doing this. Okay? Is so you can visualize. If I didn't know how to calculate that, I could be off way up here for that matter. I could be way down here. So we want to get kind of an idea of the direction that I need to walk so I know where to find it. Okay?
Okay.
Okay. All right. So on here, again, this is another practice. Make sure you try to go through this practice this weekend, okay? You don't have anything due this weekend, so I want you to spend the time to go through what I just showed you, that first example, and try to go through this second example so that on Tuesday we can draw these things, okay? And obviously I'll answer questions that you guys have. So number one, you can do solve for the bearing of each line. Number two, solve for the length of the last line. You can't do that until you draw it. Okay, so you can't do number two until you draw it. Okay, and I'll show you how that works. Number three, obviously you can't do that until you draw it because it's draw the boundary. Okay, you can't do 3A, okay, because you don't know the last distance, so you don't know the perimeter, and you don't know the area until you draw it. Okay, so what you need to do is solve for the bearing of each line. Okay, for this one. And I haven't given you any keys or anything. Just go through it and try to solve what you can. If you want to email me what you come up with, I can say yes or no and try to allow you to head in the right direction. Okay, so you can email me your answers. If you want to just try to go through a couple and have me say yay or nay and say you're going in the right direction or not, I have no problem doing that. Okay, so do that this weekend. Do this weekend if you can. Okay, we did this. Now what I'm going to do lastly, and that didn't take as long as I thought, so we talked about different types of shapes last time. Okay, we talked about circles and parallelograms and trapezoids and so forth and so on. Okay, what you do need to know on arcs, especially arcs, okay, they're going to have a radius, a delta, and a length. So what a radius means, again, let me just do so we all know how to draw an arc. So here's an arc, okay? The radius is from the center to the edge. Any point on the edge is the same distance, so that's our radius. The length is the length of the line along the arc, okay? So if I was to list that, it would tell me my radius and it would tell me my length, okay? The delta is the angle from here to here, the angle of rotation. So if I draw a line and I want to know the angle of rotation to there, that would be my delta. So every arc that you see on a map has to have those three components. If it doesn't, you should be able to calculate it. So I'm going to show you how to do that. Okay. Sometimes, for whatever reason, land surveyors get lazy or the map makers get lazy and they don't give us all the information that we need to draw it. So I'm going to give you this information right now. Okay. So the length of an arc, L, you can just say L, is your delta, degree of rotation, divided by 360. Okay, 360 is the degrees of a circle, times 2 pi r. Okay, so if we break that down and we look at both screens, okay, so let's say we had a full circle. Just to visualize it a little better, get out of here. Okay, the arc length is delta over 360 times 2 pi r. We know that circumference of a circle equals 2 pi r. Okay, the circumference of a full circle is 2 pi r. So what this component here is, delta over 360, that's just the fraction of the full circle. So let's say we had a copy 60-degree angle. Okay, 60 degrees within a 360 circle is a sixth of the area of that full circle. Okay, so this essentially would be (60 divided by 360 times 2 times pi times the radius, whatever the radius happens to be. Radius is, oops, 4.443. 4.443. This is just an example. So I multiply all that together. Pi times 2 times 4.443 divided by 6 is 4.665 feet. Okay. So this is just a fraction of the total. It's this, just this area. If I do hatch of this area, so that area is this distance. Okay. Then the sector area is basically the same idea, whereas the area of a circle, so again, here is the, we're using this as the perimeter, right? Perimeter. Okay. We know that the area of a circle is pi r squared. Oops. Okay. Why did that go away? I don't know. Okay. So this is the fraction of the area in which it encompasses. So as long as you know circumference equals 2 pi r of a circle and area equals pi r squared of a circle, you can figure out the arc length because it's just a fraction of the distance around the circle based on that delta. And the sector area is this full hatch, which is a fraction of that full circle times the area. Okay, if I list it, it tells me the area is 10.34 square feet. So using the hatch, I can figure out the square feet. But if you need to do it with math, this is how you would solve it. Okay, so if you look at your, not that, I gave you this math practice. You should be able to now go through finding radius delta length. Using that equation, you find your decimal degrees and you should be able to convert it to degrees, minutes, seconds, and so forth and so on. Okay. If you have no problems with this, you'll do just fine on upcoming quizzes. Okay. What else? I think that's it. Any questions? Chat. That's it, guys. So without further ado, thank you very much for participating and being attentive. Again, if you have any questions over the weekend, just let me know. Email me. I should be able to respond fairly quickly. If you need any guidance, just let me know and I should be able to help you. Okay? So you guys have a good night and a good weekend.
Sounds good. Thank you.
Thank you.
Thanks, Sean.
Thank you, sir.
Have a good night.
You too.